DML reference. Practice is fine. So let's start with digital logic. Right. So today date was 17. Forgot of it. Latest 12 and 172 days left. Okay, fine. So that complete 16 questions, 15 questions, 15 questions plus result from PYQs. So let us, there is binary code taken one question in 2006. Okay, so is there anything? No. Yeah, one question. Okay, consider the multiplication of 14-bit. Yeah, not 4-bit carry. It's okay. Yes, it's okay. Then so what is in this consider number is presented in 4-bit gray code. Okay. What's the present? Okay. At H2, H1, H1, H3 is okay. Big gray code. Okay. Presented in a number n. Representation of a number n, and let's even divided to be record state of Franklin's one modulo 16. Okay. Means what? After every 16 numbers, it will again move like that. 16 value of the numbers. Which one of the following is correct? Uh, just this. Following is correction. Okay, gray code. What is actually? Just the number 4-bit gray code. Okay. So here 4-bit gray code. Notation has to be gray code. So gray code and representation of a number n. Okay, the number n. It's a representation is 4-bit. Okay, 4-bit and at G3, G2, G1, G0, the gray code of and as well modulo 6. So G1, G2, G3. Okay. Value of the numbers. Which one of the following functions is correct? Okay, so what we have to do G0, G1, G2, G3. Yeah. Is gray code, but how do I call this term? G0, giving function, okay, G0 of a function, the different summation of 1, 2, 3, that G1, G1 of G1, G2, G3. What section? Right, like this is the functions. Okay, let's see the solution how they approach. Okay, this one okay. See the answer. Yeah. Actually, answer is okay. And this one like great okay. Not 60 or 5. And it's this one, 2, 3, 4. After 4, okay, after these two become interchange. 2, 3 become interchange. So 2, 3, okay. Okay. And then what curriculum was okay. Everything's same, that's not 0, 0. So if you see here 15, so we need to map midterms to respective regions. Um, and highlighted to match with all CPs. And edit no, so start the marketing. That's what would be your banded right? So 2, 3, they have exchange of 3 and 2, okay, fine. And the function, if you know, so there was and there's good, yeah, and they have incremental one and then different. Okay, see, it's cost negative 1, 6. Shit. Let's do record. Okay, please don't me. Let us do one map. Grab this last H3, H2, H1, H0, 0, 1, 2, 3, let's click on 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What is from now? Make up down. I'm speaking what's and should not use that. Okay, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, if suppose this one, right? You have to convert this into one more key map. And what? In this key map, what G0, G1, no, G3, G2, G1, G0. Okay, we do like this. 0 plus 1, 1 will become 1. Here it will become 2. Here it will become 4. Okay. Every term will increment 5, 6, 8, 7, 12, 13, 15, 14, 8, 9, 11, 10. Okay, this will grip of that. So imagine a G3. Okay, what they are going to have in terms of okay, this is what. If they're matching with this means, can we say in terms here one is matching. Okay. Not matching this. 0 is not matching, and 0 is not matching. Okay, 0 is not matching. This one is not matching, right? So my chance of let us draw. Just do the procedure. So we take is it become what you say. Yeah, so what is it also? G3, G2, G1, G0. Okay. See what is all 0, 0, 0, what is all? It is 1. Yes. H3, H2, H1, H0. I think the first has a shortcut trick, but I'm not finding it. A lot of it. Become decimal 0, 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Why up to 15? Which means these are 16 terms. The given 4 variables, we 2 power 4 plus 16. Instead of the 5. So then 0 it will be 0, 0, 0, 0. Okay, 1, 2. In Greek code, what will change? We're going to change 1, 0, 2, 3 going to interchange. 2, 3 become 3, it will become 2. And 7, 6 going to interchange. 6 and this 8, 9, 10, 11. Okay. Okay, it will become what? It will become 6, right? 6, 7, 8, 9, 12, 13, 15, 14. And after 7, 8, 9, 11, 10. Reflection first. Yeah. 2, 0, 0, 0. We're going to add plus 1. So much about to look at that sheet. Sheet 3 means what? 3 means 0, 2, 8, 2, 8. Okay. 3, 3, 4 into 1, double 0. Here, 2, 0, 0, 1, 0. Here, 3, 2, 0, 1. Here, 4, 0, 1. No, 0, here, 5, 0, 1, 0, 1. Here, 5, 0, 1, double 0, 6. This what? 0, 4, 6, 7, 7, 0, 8. Not 7 plus 1, 8, 6. Everything back. Right. Getting too long. It's 2, 6. 6 makes 0, 1, 7. 8, 13, 13, 14, 15, 16. 16 means we're going to plus 1. 16, 16 divided by 0. 14. So, what's 15, 8, 9, 9, 10, 11, 12, 10, 7. That's fine. It's not the. So, if we consider G naught, okay, for G naught, the advanced G naught. So, for G naught, what will be the max number? Means maximum 30. So, only once. So, for G1, okay, G naught means this. Now to be 0. So, first of all, it is wrong. Okay, it is not containing 0. So, for G1, G1, it should contain 1. It's not containing 1. So, for G2, it should contain 2. Oh, 1 8. G3, G2. No, still something or what? Wait, this is gray code condition, but everything is gray, right? So, if we start everything simply, so wait for 3, and share it. Some other functions. What is N? Plus 1. A2 plus G2 contain 2. After 2, 4, 5, and after 6 to 7 minutes, you have to adjust this square. So what you have to do is okay, 0, 1, 6 equals 2 is 0, 0, 1, 3, 6, 7, okay, 6, 7. 12, 13, and 1. So, wait. So, you see, telling considering yes, and for the 3, 4, for example. N is not a grey code. N is just like H is grey code. Wait. 15 and 2. So, 1 is on 0. 1, 7, 0, 0. Decimal binary. Yeah, gray and plus 1 because this feels weird that I would take connect. They have done 15. First action and one again interaction one yes x 1 0 0 1 what's equal to x1 operation. Okay, because we put this in below. So one is one is okay. Decimal to binary we have to do XOR. Okay, green to binary. K to binary we have to do XOR and plus one. First we have to do. First time it is common. XOR. Okay. Binary to actually not make it too complicated. Okay. Binary, if it is gray and 0 0 0 no, take 0 0 0 1. Okay. Now this binary if it is one free. We want to and k will become 0 0 1. Okay, how right? What we first time want to write this which way to do XOR with this right here 0 0 and then XOR we have to write it here XOR we have to write it here 1. So this is binary. So what about gray to binary? Gray to binary. This gray code 0011 0011. How to convert with 001? How to do it? So first time we have to write action. I think we have to write first term. There is some extra right here. 0 0 and these two XOR with these two XOR to write an extra 0 1 that is XOR 0 yeah. Let me do for this course. So binary token to convert character first writing 1 XOR 0 0 0. It's too slow. So then it's two binary token 1 0 0 1. First term 1. If we do exercise become 1. That's one. Stop. Okay. And create of binary. It is another process because binary hard to attack. It is strong. It is like this. So one of this and this W shape. And first is X. Write it here one. The first exert. Write it here 0 and this two exert. Write it here 0 and get exert. Write it here 0. These two exert. Get 0 1. And when say great. अरे यार, 15 right. It is fine. It is great. Great to binary. Okay. Think same processor. It means to make it 1000. It is actually it is great code. Okay. But not to binary. Just the same thing is fine. XOR with this will get XOR with this will get one. Okay. Yes. Yeah. So let us do one random thing. 15. Okay. 15 is gray code. Okay. Gray. 15 means 15 we got converted to binary. First term as it is. Okay. XOR 0 0 0. This is binary. What is a 15 binary? 15 binaries. That's not 8. What XOR 0? Wait. Sorry. I am just mugging all this stuff. Okay. Not mugging. It's like okay. Just one. XOR 1 XOR XOR 1 XOR becomes 0. 0 XOR 1 become 1. 1 XOR 1 0. Okay. 1 0 1 0 10. Yeah, got it. So binary to grid, just we have to do first we have to write as it is, and then next one we have to do XOR operations. That's all. Okay, got it. So, yeah, so after doing all this, mm, we need to map midterms G1, G2, and okay, G1 is just n plus 1. Okay, fine. N plus 1 of what? N plus 1 of gray code. No. N plus 1 of binary code. Okay, plus 1 binary. Okay, and then we have to match. Have to match what we have to match? Okay, match G what is NSP, is MSP, LSP. To find not that. I have one question now, right? Boolean algebra. What they have used. Pictures. I'm familiar with this exam, but yeah, it's right. I have written the exam. Okay, I think I need to write a part of the to test test two. This one I have written test two. Oh, okay. Test two I did not write. Let me try test two. Watch. Eating your brand new session of delicious. Okay. Manager. My stream is okay. Yes, I think everything is okay. So what is this? I 25. 3 years. Okay, what I have to do? I have this to write. Let's see where. I don't question control here. But how many mixes I have I had? Why it is lag across like it's time okay. At 27 minutes okay. 15 questions total. If we complete this test, become 16 questions total. Okay. One question. So the logical circuit implements the Boolean function such as okay. The logical circuit implements the Boolean function f equals to the given some function. It is found that the input combination x equals to y equals to 1. Okay, fine. Can never occur. What? Input combination, okay, combination can never occur. Okay, okay. Take this into account. A simplified expression of f is given by not a simplified expression. X equals to y equals to 1. Then that's nice. X equals to y equals to 1. So 2 if this does not occur. It's what? How to simplify? Could be anything else. Could be some high school to doesn't occur. Right. Yes. X dot y z. What will be z will become z dot z is 1. Okay. We'll have to z. Okay. So then what next? Okay. X equals to y equals to 1 does not occur. Means what? It means what? We can say like x equals to 1 and y equal to 0 can occur. X, wait. There are two x, y, z. Okay. One after the current 1, 0, 0. It can be occur. Z can be 0 2 cases and 2 cases 1. Okay. That's 2, 1, 0, 0, 1. Yeah. So, okay, fine. If we want, we can show. So, see, let's apply x bar. X bar means 1. 0, 0. Y bar means 1. We can't convert to couple to okay. And for okay. This first we have to face all conditions. So okay, in this condition, if we take x equals to 1, okay, x for 1, 0, y 1, that 0. So option A is strong. So option B explicit, explicit. Z explicit. Let's take this set. Okay. This condition option B is wrong. Option C x plus y. X plus y is correct. Okay, then y plus z bar z bar equal to 0 to y equals 0. In that x, we don't get x only. And z bar 0. What can that was? I think you can see the answer. Okay. If P, Q, R are Boolean variables, then P plus Q bar and P dot Q bar P R. Okay, simplify this. Boolean variables. Mhm. Okay. And simplify that. So we can take P of P common out. So we can take P plus Q bar. Okay. So then after it will become Q bar plus R. Just P is out into P bar R bar plus Q bar. So very simple. The term will become same, right? So okay, similar P Q R. So if we take P, P is always 1. Why? Because P is out. If it is 0, P is always 1. Then we left with only 2. Okay, Q. So Q can be anything, right? So P is always 1. Then P is always 1. Then so Q should be always 0. It's true. It's true. So then what is R? R can be, let's see. Q bar is 0. Okay, I remember. R can be 0 or 1. Okay. Since that, like P dot Q bar. Okay. P dot Q bar. Yes, it's true. Okay. It satisfies. What next? So people dot or bar. Notes are for we I think I'm wasting much time here from what and wait. P dot Q bar. Okay, P dot Q bar. Sorry, Q bar. What next? R. Okay, it's okay. That's all. R means hitting if R is 0 or 1. Consider R as 0, 1. Consider R as 0. Then, okay, there are two. What is R is redundant bit, but okay, like opportunity to follow it. And simplifies. It's a simplify. I mean, R doesn't matter. It doesn't matter, anything can be. So, Q actually, so we consider P R bar. Q is anyway 0, R bar, I think. That's why we simplify means R bar is redundant if I'm not false. Simplify because just following question is not in well is not evaluated to X bar. What? Okay, what to X land X land and plus not. Okay, it will become okay X land X. Okay, we are going to NAND become X bar what X bar okay. Saying not X nor X or bar. Okay. X bar is the same. X NAND 1 is 0. So X nor 1. So option C. So following is the valid identity. Okay. Okay, she's okay, and that's okay. Well, because except can be commutative. Let us closure x both ways also express me. If xy equals 0, okay. If xy equal to 0 means what? Okay, if only one term is 0. So x bar 1 means okay, let us imagine it is true because it is not true. Right? X plus y what's that? X bar plus y. Okay, let us okay, give you a damn sure. So what about so let us come into with x plus like x bar y plus y bar x. Okay, this actually this is expanding. So what they're saying x y equals 0 means possibilities both are 0. If both are zeros means then nothing is there, right? Both are one is 0, 1 is 0. Which is what is wrong. Frequency x bar is 1 and then totally it becomes 0. No, I think it is false. C is false. I want to check with B. Boolean, the Boolean expression A, so A equivalent to okay. Right. If they both worsen, then it will become 0. 0 XOR B, it will become 0 XOR B. Becomes B, just B. If it is commutative, what is commutative? Commutative and associative. Okay, then let x be a three variable Boolean function produces one. Okay. Okay, so we have to do this. Sorry, I have my time is going. Affects the oh, I did so this question. Think I need to do this question later. It's just from mark. Yeah, for the next. The Boolean variables x or the Boolean variable x, which are the following statement is a false. X dot one is x. It's true. Okay, so false. X plus one. That's one. X dot x equal to zero. Not false. Okay. What's next? Let x. Let ABC or let ABC be three sets denotes the symmetric difference. Okay, which the following is true. Okay, symmetric difference means x was if true. They're asking to true. Okay, this is true. This is true, and A plus B equals to A plus C, then B equal to C. Hmm. If A is A, which is equals to this, and let me check for I think it belongs to for check this kind of statements. Sets six means statements true or false. If it is false, suppose if A is false, suppose if B suppose let us take B is false, I mean B is zero, then what A become? If B is zero, A become A bar. Here, what is okay? Let us say what B equals zero. Let's say C equals to zero. No, C equals to one. So every quantity C equals to one. If C is one, then what it become? Become A bar. No, no, C equals to one become A. No, no, C equals to one. Hmm. A bar. Okay. If C equals to zero, then what it will become? It become A. No, it's not true. No, so because if it's not then I have a game session. B session. How can we do this? And okay, let us take AS 6 AS 0. If you take AS 0, 0 section nothing will be 0. Okay, AS 0, 0, 0, 0 section. So 0. Okay, fine. Now let's take as 1. If we take as 1, it's true. Yes, exclusive or exclusive not okay. The point is not correct. Not correct. It's true. This is also true. This is what is this? This is not correct aspects. Okay, what is this? Okay, let us do P bar Q bar. Interesting draw. If we take one complement, what it will become P bar. P bar whole bar becomes P and the Q bar. Okay, Q bar plus will become P bar as it is and Q bar cube again. It's true. Then it will be not correct because P bar Q it become this. You are playing this. Okay, yeah. You need to check this. The operation which is commutative but not associative. Okay, commutative. Associative. It's like looping terms. Okay, XOR is not. And okay, and is also and is same. Or is no, it is like there are three operations AB3, ABC. If we can associate like this and it will become same, right? Yes, yes, it was same. XOR. I mean, NAND is not same. XOR is also exclude. NAND, only NAND is not. And NAND means like A, that is not NAND, and let only and XOR is also XOR is both right, or is also and is also so following which is commutative but also C2. Okay, okay, and is commutative, right? Okay, okay. Should be commutative. Mm, like ABC looping is also equals to okay. Maybe into C, okay. Looping also it happens and also separate. So then it's fine, completely fine. The Boolean function is equal to okay. Um, what we take x bar common, it will become x bar plus xy. We should take this two and this two. X bar plus y. Or I think if I'm not wrong, it should be correct answer. Okay. X bar common. Okay. So these two comes become one. X bar plus xy. We take Cartesian x plus y or plus x plus dot one plus y. X bar plus x bar plus x bar plus y. What values of ABC and D satisfy the following simultaneous Boolean equations? Okay, equations. X plus x bar plus equals 0. Acha, fine. A equals to 1, B equals to 0. Okay, let us take this one variable and let us see which option does. We solve this from A bar plus B equal to 0. Then it will like B should be 0. Okay, option B got eliminated and A should be 1. So that's when we left with one options. Okay, and then what next? AC equals to BC. Okay, AB equals to AC. Okay. Here B is what? Here B is 0. 0. What the heck? Yeah. Like from this here, bit equals to 1, B equal to 0. Okay. So B equals 0. So if it's equal to 1, B equal to 0. If it is 0, the sentence becomes C. If we get C equal to 0, okay, C also equal to 0. Okay, we have C equal to 0. Okay, option BD correct. That's all these two. Okay. So what next? So get ABC. Okay, A equals 1, B equals 1, C equals 0. So if we get substitute in this C bar means 1. So it will become D. D equals what is D? C bar D is 0 and plus A bar B bar. What is A bar? A bar means 0. I mean, A. What the heck? No, not. Is 1. C bar means 1. Okay. And what is AB? From 0. So D will become 1. So option A will be the answer. In exam, I can't sense. So let f of A comma B equals to A plus B. Okay. Simplify the function f of x plus y. Okay. Okay, fine. Okay. So okay, steps things on which okay. So that means stress. If we have 5 minutes, so I left out 4 questions. Two. Sure, if full documents, A bar is face what is x plus y comma y. First I have to order document is full complement plus set. Okay. This is what. So here what we have to what what here we have to do. So here x plus y whole complement plus y whole complement plus z. Actually, so to make it x plus y plus y complement plus z. So it will become one. So one. I think this. If I if I true, then another 50 times what I was right. Yeah, but, so it will become x plus y. Wait, no. Shift is not right, it's not into conflict, it will become into. Okay, it is true like x, y bar, z. Okay, x, y bar, z. Let star be defined as a question equals to. I think I had done this question. Technically, cancel. This is one blunder mistake. Okay. Okay, let star be defined as x star y equals to x bar. Fine. Okay. Okay, x star y equals to x bar plus and z equals to x star y. Then okay. Then z star z into x equals to. Okay. Okay. What is z? Z is what? Z is x star y. Okay. X star y into star x star dependent x bar plus y to do bar. So x bar plus y bar this all become plus y become what one become one. Which of the following operations is counted by associated? If I'm not wrong, counted by associated x also and okay, let us do these questions. One question left out of it. Let x be three boolean variable function that produce one output. When at least output one output okay producing output one at least two inputs variables are one okay there are okay we can't say right. There are okay at least two inputs variables are one okay two input variables are one at least like it can be three also two or three okay two or three. So which are the first ones? Okay, let's say we will use this. So that means A, B, C. Okay. If you assume like given A, right to the space. If you assume what they given, A, B, C, D, E. Okay. So let us assume. Okay, we want to make first option. Assume set of ABCs. Suppose suppose C is one. Okay, C is one. And then what? And then B is also one. Let us make B is also one. Okay, D is also one. So it will become one. So we will make B also one. Okay, also one. Okay, D, C, D, C, D. Okay, at least two inputs is one. Then what? Okay, to make C, D, C, D, E. C, D, E. Okay, okay, it will become what? C, D. It will become for option is definitely wrong. It will become only ABC. Okay. ABC. We take any two, at least two inputs. Okay, man. Bro, no, at least two inputs. Without, okay. Okay, function, right? Function. Okay, function. Take two inputs, anything. One to become one. Maybe if it is one. Okay, I think B is one answer. Okay, B is one answer. Okay, B is one answer. What is this? This is what this is what this is what this is what we have. So A, B, C, D. A, B, C. Okay, let us take for actual function. Like if we take C, D, register D, yes, one of that's a D as well. And oh, 69, 5 see what's the mistake. Let's correct this mistakes. Let's so question from this question. Yeah, B is correct. And yeah, this is not equivalent to export. Option C. Why did you give option C? Right. Damn. So the question not make. Now we call such people to press so counts. Uh, yes, it's my fault. It's my speed first. And this one, okay. And option is correct. Option D. Yeah, wait, I will take some.